A very good evening to everybody here. So I think it's time for us to start off the session. I once again welcome you all to this webinar on SCM and AI. So today here with me, I also have Pavan. Pavan is the guest speaker today, and then he has many years of experience in the domain of supply chain management. Pavan and I go a long time back. And then I have seen Pavan work on consulting roles and then work as an independent consultant and also with PricewaterhouseCoopers. And now he's working through a company called as Centric. So he comes in with excellent years of experience in terms of strategizing, implementing, and right from consulting to technology implementations. So Pavan has kind of seen it all in terms of how the SCM world and industries are changing. So Pavan, I welcome you to this webinar of the knowledge sharing session in terms of SCM and AI.
Thanks, Aditya.
Okay. And then, I think now for all of you, you also have this access to raise out your questions through the chat screen here. Whenever you have a question during the course of this webinar, please feel free to raise the question there. And at right times during the session, I'll also be watching this. And then I'll read out the question to whoever is presenting. And then we can take it from there. So please make this as interactive as possible. Drop in your questions. Most of the questions will be answered here. We will read out the question and then we will be able to answer those questions there. So let me just give before handing it over to Pavan, let me just give a brief overview of the agenda we have for the day, and then we should be able to carry on with it. So we will start off with giving an overview of the supply chain system. Maybe not everybody here knows ins and out about supply chain. It actually is a very huge area, and the world's most economy is actually built on a very good supply chain management system throughout, be it the oil reaching your vehicles, the food reaching you. It's all driven through supply chain itself. And then the supply chain culture also has changed quite a bit. Pavan has some interesting anecdotes of that. And then he will also give a little bit about the digital divide that this is also bringing in the current times that we live in. And a very interesting case study that Pavan has seen through in terms of how facial recognition was basically used in one of the SCM implementations that he has been with. And then I will talk a little bit about facial recognition and different aspects of facial recognition that comes in when we say we want to look at the technology aspects of it. And then as a takeaway or the end thing, so Pavan will also take us through one more case study, which is about digitizing pallet movements. So with this, let me hand this over to Pavan. Pavan, I'll be controlling the slides. So if you want me to change at different times, so please do let me know. Otherwise, I'll catch the drift of what you're trying to speak, and I will change the slides too.
All right.
So welcome, Pavan, once again.
Sure. Thanks, Aditya. Thanks, Aritha, for inviting me for this webinar today. Pretty exciting topic because whatever you see, right from your breakfast to the way you brush your teeth, to your whatever you eat in the morning, the car that you drive, or even all your essential commodities, everything is a part of a large supply chain, right? The reason I want to mention this and I want to actually show how oil and gas supply chain is all about, to introduce you, because a lot of these oil and gas supply chain, which is not very common to us in day-to-day activities, is a part of oil and gas supply chain. For example, the chair that we are sitting on, be it, let's say it's a plastic chair, it's a part of petrochemicals, which is at the end of the day will link up to your crude oil, right? So it's a very large, lengthy chain. So I'll introduce you to supply chain starting from oil and gas, and then I'll give you some parallels to manufacturing, automotive, so that you'll get a grasp of how large or how big supply chain is all about. Now, quickly going through how supply chain spans right from crude oil, because it's called as upstream supply chain. That is, until the refinery, it's called upstream, and then it's a downstream part of it, right? Post refining and distribution. Now, the names that we hear, HPCL, IOCL, and all those state-run companies are a part of downstream, because at the end of the day, they buy crude from companies like ONGC, or at times they also import it, right? Reliance is one among them, who's generally in the upstream, but also, their downstream didn't work, but that's a different part of the story. So what's upstream supply chain? In upstream supply chain, it goes up till the raw materials, right? Here, in this case of oil and gas, it's the crude oil, where you actually you take it out from the ground. It might be from the onshore, it might be from offshore. In the sense, might be somewhere deep into the sea, or it can be onshore, right? So here, companies like ONGC, they drill down. Of course, there are service providers like Schlumberger and many other companies who actually help them. Now, once the crude oil is extracted from the ground, you actually send it through crude tankers or through a pipeline straight into the refinery. Now, in the refinery, you refine, in the sense you just clean it up. So generally the entire crude, everything is made use of it. In the sense, the best of the best crude, which just get refined, comes out as petrol and your diesel, and then comes your ATF, then comes your petrochemicals and your lubricants. At the end of it, you have bitumen, right, which is tar, that's used for asphalting the roads, right? So all along these supply chain, and then you have the sky tanking and Indian Oil Sky Tanking and other companies who actually store these products. Then you must have seen getting these petrol and diesel getting distributed to our nearby bunks, and then consumers like me and you use it. It's a very large chain. I'm just giving you a perspective about from where it starts to where it ends. Now, drawing parallels to this would be an automotive supply chain, a car manufacturing company, be it Hyundai or Maruti, for example. You have the raw material suppliers. The raw material suppliers supply your raw materials in terms of your rubber or probably steel. So they extract it from the they're all natural resources, right? So they extract it, post which you'll have forging and many other machining done on those parts, casting or forging, then moves on to further down chain. Then from these steel coils, which you might have seen being traveled in the trucks, right? These steel coil being broken up, put into furnaces, then they're machined upon different castings and forgings, and to whatever shape you want it. Now, this is being used by automotive manufacturers in terms of your auto parts that gets into your car. You can take steel, you can take rubber, you can take wiper blades, right? You can take anything, including your doors, which is a part of your sheet metal. Right? Like this, there are different various components that comes to the car factory, and then it's assembled, pushed out to the distributors, dealers, and then finally, you go to a showroom and buy a car, right? So, and then after sales services would definitely kick in. So, all through this entire supply chain, if you just think of how it works, if it were not to be technology, it's very difficult, right? It's very difficult to work. It's very important that each of these players or stakeholders along the chain are connected to each other, right? Now, only if they are connected, they talk. Now, why I'm giving you this perspective is because how it used to work before, right? The culture of the entire chain. How was it, and then how is it now? As Aditya said, I first cover the culture then. Now, ideally, if you look at before 2000s or 80s, in fact, I'm not saying it's not present now, but then the ecosystem itself was very top down, right? There's something called channel master in the supply chain. In the sense, if you take a car manufacturing company, the manufacturer, right, the OEM, original equipment manufacturer, is actually the channel master. When I say channel master, he is the master for the entire channel, right, from raw material source to your final distribution. So he owns it, he controls it, right? He manages it, and then he says what needs to be done. He directs it. So the channel master would say, okay, I need to buy from this supplier at this particular cost. At the same time, I would want to sell it to these distributors by giving them only these margins. Correct? So the channel master used to initially decide. He decides, he controls the entire chain, and the chain works according to him. Now, at the same time, when he decides and controls, when his span of control is huge, naturally he eats the cake. In the sense, there's a lot of margins that he enjoys, right? So he squeezes the suppliers on the upstream, on the supply side, and he also squeezes the margins or gives lesser margins distributor on the demand side, right? So he enjoys and he eats the cake. At the end of the day, he used to grow alone. He said, "Hey, listen, I'm the OEM. I have the patent. The engine is mine. The design is mine. You're just suppliers, or you're just customers to me, right? So I have to enjoy the cake because I do all the hard work." So there was no collaboration. It was all these players, different stakeholders, were never seen as business partners. They were only seen as different companies, not talking to each other, only joined by a commercial contract, and hence it was always having a challenge. Now, this is on the ecosystem perspective, but looking at an organization perspective as well, huge hierarchy, bureaucracy, decision making only at the top. It's more of not a laissez-faire or a democratic. It was more of an autocratic organization where the top makes the decision and you just have to follow. The mid-level management and the operational levels would only execute it. Their job is only to execute. So the entire culture in an organization is to be top down, and you piss off the largest stakeholder. Let's say be the promoter, and then you're gone. You're out of the job, right? Or you're out of business. So that was the culture back then. I'm not saying the culture is not present now. It is, at least in the areas of SME, it is, right? But then this was earlier culture. So naturally, what happened when the channel master started eating the cake, he had, of course, he had a lot of money, he had margins, he made money, and then only those guys, channel master, grew very fat, and then they sense that, hey, listen, now that I have a lot of money, let me start implementing technology into my system. Or slash, in other words, now a newer perspective in these times is that you have funded organizations, right? It's not their money, they've not worked hard, but then it's funded, either VC or PE funded. These funded organizations have a lot of money at their disposal. So they would want to use technology without knowing whether it's going to help or not. However, irrespective of it, the companies have money at their disposal. They use technology now. Now, what are those examples? Large companies have built bot for their forecasting, prediction, planning, right, including your manufacturing planning, RCCPs, and other things. So what do these bots do? They actually will say, hey, listen, this was the last 5 months or 10 months forecast, but then these were the issues there. Now I think going forward, this is the demand. This is going to be the demand. So these bots will actually program and will give you a output. But all this is happening as I said, at an organization who has money at their disposal. But what's happening to the other end of the chain, which is from the supply side? These suppliers are still working the same way as they were, because the channel master squeezed their margins. The channel master always said, hey, listen, if I have to buy from you, this is all I can give you, right? You can't have your margins. It has to be cost plus. When I say cost plus, you give me your cost upfront, everything transparent, saying that my cost of producing this part is 100 rupees. I'm going to give you 5 rupees margins, which is 105 rupees. So if you squeeze it to that level, the suppliers, of course, we all know, suppliers, they all form part of SMEs, generally in India. 60% of Indian manufacturing is all part of SMEs. They don't have money because they're all entrepreneur-driven, family-driven organizations. So why am I bringing this? This aspect is because there is a digital divide. In the sense, smaller organizations cannot implement technology as much as what we expect to. Larger companies are, but then they're forcing these smaller companies to implement it, right? There is a divide, though the divide, the gap is actually closing in. Especially in these days, because even the smaller organizations, when they are patented, when they have their own capex and capability to invest, they are getting in some technology. So I'll also tell you in the following slide as to how the gap is closing.
Yeah. So Pavan, here I had a question. So all these, do you think all these e-commerce tech giants, they're helping us kind of bridge this digital divide, or are they adding to it?
Absolutely, it's both, Aditya. For example, if you look at e-commerce companies, right? So they have very large suppliers who they call as strategic suppliers, where they would say mandatorily, please go for these technologies, right? Or they would say, I'm ready to offshore or outsource strategic outsourcing certain activities, but for that you have to implement technology, and only if you do that, I'm going to give you some additional work. However, they are also aware that certain suppliers are single owner suppliers, right? They're all homemakers, especially companies like Misho and other e-commerce companies. They buy from smaller organizations and they sell it to tier 2, tier 3 organizations, right? So they don't force, they only buy. So there's definitely, yes, e-commerce has changed a lot, and they are also changing the ecosystem.
Cool. Interesting.
All right. So there's an interesting thing. This was back, I think, 5 years ago when we did this project with in association with IIM Bangalore, where one of the companies wanted. This is when I was actually freelancing. One of the companies wanted to understand. They had a product, they had a technology product, but they were unable to sell in the market because they never knew why they're unable to sell. What's the pain point of an entrepreneur? And their product was focused towards SME. So we did a primary here. When I say primary market survey, where we designed a questionnaire, statistically designed a questionnaire, then primarily went out to the markets, met the entrepreneurs. We met about 110 companies, if I remember, in Bangalore, Hosur, Chennai, Pune, and I think Hyderabad. Yeah, Salem as well. So predominantly manufacturing companies, automotive or any other manufacturing companies, and we met the entrepreneurs, owners. We also met the middle level management and also the operators there, trying to understand what might be the reason that they don't have technology. Well, when I say technology, right, I'm not telling they need to have AI, ML, or data analytics capabilities. I'm only saying that why not have a simple planning system? I'm also not saying you need to have SAPs and Oracles of the world. But then simple systems which can help you run your business day to day. They don't cost much. They're all available on SaaS basis. But then why are they not adopting? So we went with three hypotheses. All three hypotheses proved to be right. One is, of course, awareness. Yes, they weren't aware. The entrepreneurs, though they were aware, I mean, partly they said, okay, we are aware, but then we don't want to invest because it's not a priority. And in the mind of an entrepreneur, using the technology, of course, would help you in many ways. At the same time, it's also a disadvantage to them on many other ways, right? So they said, listen, we are open to it. We have smaller softwares applications like Tally, which is doing its business. I think we're happy with it. At the end of the day, what matters is we do assembly, we do small manufacturing, but then Tally is taking care of our invoicing. We're not really bothered about your tracking, your tracing, your forecasting, your production, your raw material. I don't want to connect suppliers or customers. I'm getting my job. I'm doing it. That's enough. They were unaware of the strategic benefits. When I say strategic benefits, what if you connect to the larger ecosystem? What will happen if you connect to your customer, right? Give him visibility, because uh, generally the KPIs in the supply chain say it's three V's, right? Velocity, variability, and viscosity. So what happens here is, and sorry, variety. So here basically the fast, right? The variation, and also the openness, the transparency is the three V's of a supply chain. So they're unaware of these strategic benefits. At the end of the day, an entrepreneur is definitely interested in his profits. Of course, he is also taking care of his employees, but why not think beyond it? But then now time has come. So our awareness hypothesis was proved right, saying that yes, they are unaware. The second thing is the maturity. They said, hey, listen, we are busy firefighting on a day-to-day basis. When we said technology will help you overcome that, because technology is intangible, they don't see technology the way they see a machine part, right? Or a physical manufacturing part. They feel technology is heavy. So we really don't want to go for it. And especially in terms of affordability, they say, Well, we can afford, but then a larger part of their profits is shared between the partners, and hence they don't have the concept of pulling in reserves and surplus and reinvesting it back to the company, be it in technology, be it in new machines, capex, expanding to new areas. That's a little difficult, right? So affordability, they don't even have the concepts of budgets, technology budgets in their year-on-year budgets that they plan. So if you look at this, right, affordability is the last, in the sense the cost was the last. So which means SMEs do have money at their disposal to some extent, not to a large extent, but then it's more of awareness and maturity that we thought, okay, this is the primary concern, and that's exactly the reason. Also, the factors that is focusing on digital divide, even these contribute.
Okay. So then who are the guys who are actually implementing AI in this whole system then?
Well, as I said, Aditya, right now it's a mix. Now, if you go to the next slide, I'll tell you what's happening. The same suppliers who are saying, I don't have systems, or rather, I don't want to implement in systems. Now, the channel master or the entire ecosystem and the peer pressure is actually making them invest. Now, the channel master is saying, see, there is a laggard. You have people who are innovators and also laggards, right? People who come first and also they would adopt it last, or laggards. They said these guys who come first are proactive in implementing it. Probably they are funded, or probably they are not, but then who come and actually invest it, right? They have found the benefits. The companies, the channel masters have found the benefits. So hence they say, hey, listen, if you can do it, why can't the other supplier do it? Probably the supplier might need some financial assistance, support, fair enough. As a channel master, let me coordinate, right? And let me help him get that loans, talk to the banks, and then because they have the buying power as a channel master, and then based on that, they are getting loans for the smaller companies. Hence, the first point that you see is nowadays you see more collaborative approach across the ecosystem, right? There's also a concept called CPFR, collaborative planning, forecasting, and replenishment, especially in this area of supply chain. When you don't know what the forecast is, your companies would say, hey, listen, I need 500 cars. Or they say, we might, in software services, they might say, we are getting a project, why can't you staff some 10 people immediately, right? And then you start interviewing from 50, 60, 70 people just to hire 10, if not 10, at least 8 or 9 or 7. You get them, they are on bench, and the client says, hey, listen, not now, probably 3 4 months. Who's going to take all the brand, right? So this CPFR is a concept where you collaboratively forecast and plan along the supply chain. When I say supply chain, it can include even technology supply chain, right? So it's more collaborative in nature. And nowadays, as I said, technology is deciding. One of the projects that I remember is we were doing a project for a fishnet manufacturer, and then he said, listen, nowadays whatever I forecast, it's going wrong. How is it possible? The weather is changing very rapidly. And then when we went to the manufacturer, he said, he gave us a list of his SKUs, or the item numbers. He said, these are the varieties of fish nets that I'm capturing. But when let's say in the month of June, when the rains start, I manufacture this fishnet number one and give it to the company. They give it to the dealers, and these guys give it to the fisherman. By the time fisherman fishes it, the fish net is so broad that all the fish will squeeze into the net, right? So he said, no, then this is the wrong type of net. We'll have to bring in some of the new net. Now, what's happening if you bring a new net? By the time the winds, the cyclones have changed, right? Probably there's a new cyclone which has come up, or the wind's directions have changed, and the fish will move away. You won't be able to catch it. So it's a larger problem. So we said, why can't technology decide it? Why can't we put up a model where we say, we'll take up data points from the Met department, we'll take data points from the local farmers, fishermen, right? We'll also take data points from other areas and then collaborate. And even if 1 or 2% forecasting increases, then it's going to be a gain, especially for FMCG companies. For a zero point 0.5 or 1% increase in forecasting accuracy, it's going to be a huge gain. So these days, technology is deciding. It's actually it's enabling people, and because of this, they're also taking other people along the ecosystem, right? One supplier through the word of mouth, because SME is one area, right, which is very closely knit. So one person says, hey, listen, my ROI was hardly 1.5, 2 years. You could also invest 50% from the company, 50% yourself, and then that's how they decide and then say, okay, let's go along and start implementing it. So that's where so people are adopting and they are adapting to the newer ways of working. So
So, Pavan, there is
that's
a question here which says, what kind of technology is being used in these in these?
when you say in these, can you be more specific?
As in all these SMEs and all these the case
Or
study that you just gave about the Fisher.
So it's varied, okay, varied. But our study says more than 70% they use Tally because it's one easy to use. Second thing is I don't think so. It needs a license. Probably even if you need, then it's not much. But there are 30. The remaining 30% is again scattered. Few have SAP B1, which is SAP Business One, predominantly for SME business, which is not very costly. People I've not seen Oracle much, but there are many other free source, open source systems that people use. So it's varied, but
But
predominantly
all the big guys, the channel masters and
the channel masters generally go with. I mean, the big people, right? JDA, SAP, Oracle, right? And but these days it doesn't really matter because I'll tell you in my case study why is it not really mattering, because it's a EDI, right? To EDI people are connecting, but the larger guys are definitely will go with the big guys like SAP and JDAs. Right. All right. So now that we've spoken about um, these technologies and how the culture was then, but then where's the culture improving? Let me give you an example of where we are getting to. When we say the culture is improving now, and then when we're saying it's more of a all across the ecosystem, people are getting together. This is one such example I could give you. Now, this is for a FMCG player where they said, see, listen, we have SAP that they use for procurement planning. Once once the planning is done for the next week, next month, or next 3 months, they send out the planning from SAP through an EDI to the supplier system. Now, after the supplier manufactures those items, he will acknowledge again through an EDI. It will come back to SAP to say that, okay, my parts are going to be ready as you said. My manufacturing is going to be ready. I will start sending it to you based on your schedules that you have mentioned in the purchase order. Now, once he does that, there's a copy that goes to SAP back to the planner, and a copy which is also SAP, but a EWM, Extended Warehouse Management, that goes to the warehouse guy, saying that, okay, this supplier is probably coming now. And then he's bringing these many goods. And then let's agree to what supplier says. Let's create a platform or give him some space when the vehicle comes. Well, the supplier dispatches it. Let's say he dispatches it today. There's an ASN, which is advanced shipping notice, that the supplier sends again through an EDI. The vehicle comes. Now, once the vehicle comes, they said there are a lot of vehicles that used to enter into the gate, and then every time you will have to enter these details of the driver, the document, and then what's inside the vehicle, which is your purchase order, your invoice, and other things. It was manual in nature, and luckily, this FMCG company had 60 to 70% of the drivers who used to be regular drivers because they had leased trucks. They said, if the same trucks and same truck drivers are coming, why can't we automate it using facial recognition? So we put up a Raspberry Pi camera there. We took up their photos, different angles, and then finally, as soon as the vehicle comes, it reads both the number plate and the facial. It recognizes the faces of the driver. It will go back to the database to check, okay, if this vehicle is about to arrive, is it there in the database? Yes. Then the gate opens. Now, once the gate opens, he goes back, then loads, unloads, whatever work he has to do within the warehouse, and then post which he'll have a time to come out, then he'll come out. Now, the systems here we used were, as I said, SAP. APO, SAP planners, then SAP EWM. Then we had supplier was using a different technology, different company as in, and then we use of course Raspberry Pi camera hosted on the cloud Azure, and then we had a couple of other all through timestamps through APIs. These things got together and then we planned it. Now at the end of the day, the important point here to be mentioned when I say facial recognition is we extended this to an external party, which is supplier, right? So over a period of time, this model, this algorithm, if you want to develop it or if you want to update it, you could go update it, and then it will start learning different faces. Probably the driver comes with a beard, tomorrow he comes with a cooling glass, or there's a bit of dull light and other things, but still it learns. Once algorithm learns, then the gate is going to open. Now, yes, if you ask me what was accuracy was 98%. 2% fallout because of certain conditions that are not in our hands. For example, there's an accident, the number plate is broken, it's dented, probably it's raining. So many other external factors that we couldn't really capture, but then that's still fine. 98 was a good number. So this is the overall facial recognition from a functional and technology integration standpoint.
Okay. Pavan, there is a question about so for the EDI process, how does it work and what kind of application system or application or source is used?
Well, see, it's EDI, right? So generally it's either flat file or through XML. It doesn't matter which system you use. You might be using SAP, somebody else might be using Oracle, or you might be using even Tally, but just that these smaller softwares should have the capability to integrate or read these XML files and then revert it back in their respective fields. If the capability is there, then fair enough. If the capability is not there, then we'll only receive it from there. For example, a supplier has only, let's say, XYZ system, let's call it Tally, for example. It doesn't have the capability to receive. So it has the capability to send out information. At the end of every day, either through an online or a batch process, every night you'll send out how many invoices are being sent out tomorrow morning, how many are being packed and shipped. That through a batch process, a flat file or an XML will move through an EDI, through a HTTPS connection. It will come to your STP, and then you would have mapped the files, fields, right? If a supplier says invoice, that invoice might be a bill number according to you. So you map the fields according to those fields. It will come and fall into your system, and then accordingly, okay, he has sent an ASN, and then you can integrate it to the further actions there.
Okay, cool. So now from this facial recognition thing, so one thing that I have come across, as a technology guy, and when I talk to these business owners, so one of the first hurdle I face is how do you prove the ROI of it, and what was the ROI in this case by bringing in facial recognition? What was averted, and how would you substantiate that ROI?
Okay, so good question, especially in terms of ROI, right? There are variables here. The variable is depends on the operations, depends on the company, and also depends on the financials that the company generally accepts. For example, few companies who I know, European companies, they are generally conservative, but then they're very tight in terms of financials. They say they don't need an ROI, anything more than 1.5 to 2 years, they're not going to accept. Point one. And of course, your NPV has to be 0 or positive. Your IRR has to be anywhere between 18 to 20%. Anything less than 18%, only if it's a very large project, they agree. And hence, your payback period anywhere between 2 to 3 years. So now this is one part of it. Second part of it is it depends on what infrastructure you use, right? So do you want your Raspberry Pi camera to be capturing it online, and then online should it actually send it to database back in the cloud, or do you want a model where you can keep the model running it local, and then because the Raspberry Pi camera has this capability of running it locally, right? So do you want it to run it local so that it's faster, and then or let's say batch process update the cloud back on your on the vehicle database, number of vehicles that came today, and other things. A lot of these things would matter. The processors that you use, GPU that you use, and many other things matter. And also depends on your application, how far is your vehicle from the gate or from the camera? Are you is it a portable camera that you take and then keep it in front of the way, the driver, or is it 15, 20 feet distance? It is automatic, or how it is? And also, do you want to automate the gate, or do you want to open the gate manually? So a lot of these variables matter, but then it depends on also the companies and other financials. But then I think anywhere between not more than 1 year should be a right check.
Oh, okay, cool.
All right. So
Yep. So let me take over from here, Pavan. Let me give you a bit of rest there. So now the easy part, right? So Pavan just gave an overview about the whole SCM world, and then there is this whole implementation of reducing the times by which an entry and an exit happens, and arrive at a more predictive model of the advantages of bringing in facial recognition at the gate entries. And then all this is driven by technology, but technology by itself doesn't solve a purpose. And only if it solves a purpose, you get paid for it and all those things. But then this facial recognition in the recent years has uh, basically contributed to quite a lot of buzz. It's contributed to quite a lot of use cases, right from biometric entries to verification use cases like Pavan just spoke about. And then very simply put, we say facial recognition is basically I want to take a face and match the face against a database of faces. The input to this can basically be a digital photo or a video frame. And all of us, I think, at least at this point in time, we've come across uses of facial recognition, at least in terms of at a consumer level, at least in terms of Google Photos. Google Photos basically helps you automatically categorize the photos that you have. So you can basically choose a particular portrait, and then it says all the photos that that person was present in. That's a cool thing to have. And then there is also this facial recognition block on most of the mobile phones. So because you are opening it, it figures out who you are, and then it allows you in. So why I specifically bring these two different use cases? The first one is a lot different. The first one is basically it says the Google Photos. What it basically does is it's basically doing a similarity check. So I have a new photo coming in, that is the photo that the user has chosen, and then I have a database of photos with me. So what all photos really match the incoming photo is what Google is basically doing. But the facial recognition lock on the mobile phone, I would say this second part is a lot more easier. Why I say that is, in the facial recognition for lock, you basically have a photo that is captured and a photo that is already there on the phone. And all it's doing is extracting some features from the incoming photo and checking the features that are already put on the existing verification. And it's only basically doing a 1:1 kind of a verification for the photo that is coming in. So the second one is a lot more easier from a process perspective. The first one is a lot more process intensive. That's why you have to upload your photos to Google so that some batch can really run and build in some models and build in some scores to the photos that you have uploaded. And then all this recognition can very quickly happen. But the second one can really be embedded into your mobile, and you don't really need to go to internet for you to do a facial recognition verification. But in this facial recognition, even though it seems like all we are basically doing is bringing in two photos and then comparing two photos, there are a lot more to it. When we reach to the challenges that are faced in a facial recognition system, we can talk about it. Different ways in which it works there. We pick out some distinguishable points on the face and we call them as facial features. High cheekbones, double chin, low arc eyebrows, round face, all these can be something which measure the facial features. And then now when you say, okay, these are all the facial features and I can use these facial features to compare to photos, how do you define high cheekbones? Right? You don't know. These are all can be subjective, but the point here is to convert this into a mathematical model. What it basically does is, it picks out, we might choose to define that high cheekbones is basically defined by the maxima point on the cheek, that is the highest point on the cheek, to the center of your eye. So if that is larger than the average, then you don't have high cheekbones. If it is smaller than the average, then you have a high cheekbone. That means that you also need to know what is the average. And that means that this average also differs from demographic to demographic. The average for Chinese might be different from people from Africa, might be different from Indian origins and things like that. So what we are at the end of it basically doing is, a face is a mathematical model of all these nodal points and all the arcs connecting these nodal points, basically this type. So the number of nodal points also will help us decide how accurate this facial recognition is. Pavan brought up a point saying that there was a 98% accuracy. That's pretty high considering it was not a controlled environment, right? Somebody is at the gates, so there is rain coming in, there is dust because there has been so many vehicles passing by. The driver himself is so tired. The lighting inside the driver cabin is less. So there are a lot of variables that are affecting the accuracy of a facial recognition system. 98% is still very, very good. Right? And then, more importantly, when we recognize people, we have been trained. So there has been some amount of machine learning inside us, which basically says, I know how to recognize this guy, and then I attach him with a name, and that becomes his tag, and I can recognize people. But then, even as our facial recognition system is so limited that if you're put in a different demographics, your facial recognition system will go for a toss, as in your internal facial, biological facial recognition. If you're put in a demographic which has mongoloid features, and if you are from a different demographic, it becomes very difficult for you to do facial recognition. And similarly, very interestingly, identical twins here. So they are identical for most of the populace. But then for the twins' mother, she can really distinguish between two twins because her facial recognition system has been so fine-tuned that she can pick out even the minor of the changes of between these nodal points and the arcs that are happening within it. We don't really pay attention to it. It all happens subconsciously and very quickly. And one more interesting thing that I came across is, if you're not a shepherd, then for you, all the sheep are same. But even for somebody who is really herding hundreds of sheep, they can really identify and name sheep. So that means that, shepherd's facial recognition system has been so good that he can really figure out different facial features of different sheep that he has. A very interesting thing. But now the point is, if we take this kind of a facial recognition system and not really trained through demographics, and if we can bring out a model, a mathematical model out of it, we can really put that into software, and that's how we can start to bring in facial recognition. And that's exactly what is happening. So some of the different stages that basically happens in a facial recognition is, more importantly, given a photo, we really need to identify what is the face in the photo before we can even put the nodal points on the image. We need to identify what is a face. So that's the first step of it, the detection phase. So in the detection phase, a lot more algorithms come into picture. A 12 net, 12 calibration, 48 net, 24 net. So you basically go through different stages of it and finally arrive at what is it. So when you really start off, it might figure out that there are basically 12, 15 faces in the photo. And then after the first one, it boils down to, it thinks that there are 8 faces and then 4 faces. And finally, towards the output of it, it says that, okay, now I have figured out there are only 2 faces in the photo that is given. So this helps us detect the range in which a particular face is. And once you have figured out what the face is, next is to extract the nodal points out of the face. So the face might be turned, they might have made an expression, and they may want to pick out different nodal points on it. And that's what the extract phase basically does. It extracts all the nodal points that are there. And remember, all this needs to happen at runtime. It needs to happen at very quick paces, at very quick times. And after this happens, we get a model score for your facial recognition. You've got a score. And once you have the score, now two things can happen. Either you query a database, pick out all the other photos that you have, which have a similar model score, and then you say, okay, all these guys are similar. Or you can also, just the verification thing, you can just check the model score of the existing photo and the model score of the incoming photo, and then you say these two match. So whichever route we take, the Google photo route or the phone unlock route, it has to go through the detect and the extract phase. Every photo needs to go through the detect and the extract phase. The bigger grunt work is in maintaining the database of it whenever we want to fetch out similar things, because now I have to run this algorithm over and over again of millions and billions of photos that I have been getting. And more so, if it's a video and if that video is split into frames, then I have those many X number of videos, photos that I have on which I have to run a facial recognition algorithm. Very interesting different stages that come in. And then more importantly, the challenges that we come across in a facial recognition system is we cannot really take ideal conditions when we want to do something like this. Lighting or illumination, what we call as, plays a major role, because that's what is basically helping us figure out how one pixel is different from another pixel. And then the pose, I might go in and I might define, generally in a good facial recognition system, there are actually 80 nodal points. I might have decided I have these 80 nodal points to identify a particular photo. But then that person might be slightly turned away from the camera, or you might only get a profile view, or you might get a view which is not the way you want, but this has to still work. This is where the machine learning probability things come into picture. And then there might be blocked areas as in a headphone blocks. And then if you look at the previous thing, here there is shades which are basically blocking the photo, and it might even be a beard, right? So when the first facial recognition things came in, it could not really differentiate between a person who had a beard versus a person who had glasses, and it was easy to cheat that kind of a system. But over the years, it has also become a lot more different. So I think there has been a question there. Let me see if I can pick that question. I don't see the question. If Pavan or Ramesh can read out, it would be easier. Okay. So
I think there was a question from Aman. Why don't they go with big guys? Can you help me elaborate this question, Aman, please?
Okay. Yeah, while that comes, I'll just proceed and maybe we can keep it to the Q&A there. And the expressions, so laughing, he's something, and then low resolution, aging. Yeah? Aging also moves the nodal points, basically. On a younger phase, the nodal point might be here, but then as the same phase ages, the nodal point will basically come down, and because of all the wrinkles and all those things. So how do we still make it work even with the aging process in there? And then the biggest of these things are the ethical challenges that this comes in. So how reliable is this recognition? So can I say because two low resolution pictures of an ATM robbery matched, can I say, okay, this guy is really the culprit? Or is it really good for me to hold all the photos of my users, whether they are on the system, not on the system, they have approved, not approved for me to use it, and then all those questions. So there is a bigger ethical thing. So while trying to build these slides, I was basically looking at searching for a picture which helps me with illumination, blocked areas, expression, and resolution. And I was looking at Creative Commons license images, and luckily I somehow got this blogger, and this is the typical test case when you really do a facial recognition system, and he kind of ticks all the things, yeah. So low lighting, different poses, different expressions, and blocked areas. So this was a good picture for me to get. So these are the many challenges that a facial recognition system brings with it. So now, how do I start with trying to build a facial recognition system? Do I start from scratch, or are there, it seems like a pretty common standardized implementation. Are there different vendors or different systems that I can use right off the bat? For that matter, yes. The pricing of it is a secondary question in play. But then the last one, if you're trying to build out something that you want to on your own, then there are a lot of deep learning algorithms and models available for computer vision. And then FaceNet by Google, I think that was one of the first that came into picture in terms of building a model for faces, and who better than to hold the faces of the people of the world, right? So Google has basically come up with this FaceNet. It's a model, it's an algorithm. You don't get access to the actual faces, but then you can use this model to define your whole facial recognition system. And interestingly, AWS and even Google has it, apart from the FaceNet. Even Google Cloud also has this recognition API. AWS has a system called as AWS Recognition, which helps you, I mean, you give it a photo and then it helps you to label all the different photos. It helps you to figure out, okay, in this photo, there are 4 people, and on your database, this person 1 matches with people 3 and 4 on your database, and AWS recognition is a good one. So at this time of technology development, facial recognition is one such aspect of AI. AI and ML, there are a lot of things that are happening still in the hype cycle. A technology hype cycle is basically when any technology comes into the market, there's a lot of buzz around R&D. There's a lot of money that gets pumped into R&D, and then it picks up a lot of jargon, and it reaches frenzied hype in terms of the technology. And then when businesses come in looking at this hype, and when they start
Well, I don't know if we lost him or did I lose myself.
the frenzied we falls from the frenzied hype cycles and then falls into an implementation plateau. So that implementation plateau is a good state for any technology to be in. That means that it has another 10, 15 years of fuel left in it. So facial recognition basically has reached that place. There has been a lot of improvements in the algorithm, and we are talking in terms of 0% improvements when we talk about different facial recognition systems. So that's how neat these implementations have begun. And one of the cool things is also about, if you look at Lenskart, right? So Lenskart has a good 3D imaging system wherein it figures out your face and different aspects of the face, and it helps you to try out glasses or goggles on the net virtually. Yeah? So it's a good thing to try out. So that way, facial recognition is becoming a very commonplace software. Okay, cool. So now we come to the last aspect of it. So we just spoke about one use case that Pavan spoke about, which had facial recognition system in place, and then we looked at little different aspects of what facial recognition does. And maybe in a follow-up session, we can do a deep dive into the technological implementations of how a facial recognition system works. But staying true with what we are talking today about SCM and AI technology in SCM, Pavan also has brought up another case study for us as a takeaway from this. Yes, Pavan, would you want to proceed with this?
All right. Yeah, I think understanding the paucity of time, I think I'll brief this in a very high level, because I wanted to bring up this particular case study, especially when I'm talking about the entire ecosystem of players in the entire supply chain, right? So when I mean digitizing pallet movements, there was one company who wanted to track their pallets. They wanted to understand what goes on the pallets, what materials are tied to the pallet, the journey that the pallet makes from source A to destination A, and then where all it travels, which route it travels, the overall journey of the pallet. And hence, the project was to understand what tools do we need. Here we have stakeholders like suppliers, we have plastic pallet manufacturers, and then we have logistic service providers who carry those pallets, and then the manufacturing company who actually places those finished goods on those pallets. And then again, you have truckers who move those pallets from factory to the warehouse, right? And then using RFID chips, using handheld scanners, static scanners, and all this tied together to a control tower where the head office, the channel master, is viewing what's happening to their pallets. Is there any damage? Is there a delay? Is there a pilferage? The overall journey of the pallets. And hence this particular case study, though I'm not getting into the depth, I'm just giving you a view of what this entails, right? So this entails a third-party service provider or a transporter taking the pallets, registering the pallets in a system using RFID, which is imbibed or embedded within the pallet, takes the empty pallet into the factory. The goods are loaded onto it. But then before the goods are loaded, you scan it through a handheld scanner to see that, okay, now the empty pallet has come from point 1 to point 2, the goods are loaded, and that particular goods, the PO or the invoice is interlinked to the pallet movement, that everything is uploaded onto your cloud, post which it moves to your warehouse or a distributor who will store the pallets and will use it for further distribution to retailers, retail stores, and then many other areas, or probably to a subcontractor. So the journey that the pallet takes from upstream, from the pallet manufacturer to a FMCG manufacturer to a warehouse distributor, all along using these many stakeholders is actually the case study that I wanted to mention. And the technologies again used here are RFID, your barcoding systems to some extent, your scanners, handheld scanners, and of course other cloud areas, right? So now why I'm giving you this view is so many stakeholders are now involved in ensuring that there is visibility in the supply chain. Though there is variability, there is better velocity and visibility in the entire supply chain, and everything is interlocked, interconnected to, and then visible in a control tower. Now the control tower is where you actually control. You have dashboards, your MIS reports for your management. Now we can say that upstream part of the entire supply chain is connected. We know what's happening. We know the health of the system, right? So that's where supply chain is moving towards. Now people are getting together, either within the ecosystem, either they are investing on their own, or they're getting help, or they're getting funded. But then definitely the world is moving towards technology at large.
Cool.
So
On this point,
this is a quick overview for me to give away, because this will give an overview of how interconnected the system has become.
cool. Yes. So on this point, especially on this use case, right? So the AI and ML plays an important role at two different places. One we call as edge-based AI ML, wherein so in all these systems, what kind of machine learning algorithms and artificial intelligence I can bring in at a gate level, at a scanner level, or at even a conveyor level. And then once all these communicate data, and then we put it into some kind of a data lake in the cloud, and what kind of other algorithms we can run on the top of it. So there are, when we take about ML/AI implementations, so it can be at the edge, or it can be on the cloud, wherein we use that to draw different things. So yes, so as Pavan says, SCM is one area which is a lot of AI ML implementations and case studies, and people are really looking at it. Drone-based camera recognition, image to character recognition implementations. Facial recognition was definitely one such that we looked at, and many kinds of fraud detection, prediction algorithm, just-in-time inventories. So all these kind of things can really have become a very easy implementation, and supply chain management creates tons and tons of data. So it's like a data engineer's gold mine, basically. We can do a lot of it with it. So with this, we have also come to the end of this topic of SCM and AI. We plan to conduct follow-up topics on it where we can do a lot more deep dive into the technology aspects of it also. So with this, Pavan, thanks a lot for coming in and talking about the SCM. So to hear it from the horse's mouth for somebody who has really done it and then worked with the supply chain management companies. So it was really very insightful. So thanks a lot for spending your time here. And to all the attendees also, thanks a lot for spending your time. So hopefully this 1 hour that you spent here gave you some ideas and made you excited about the opportunities that can be there in the world of SCM, AI, ML areas. So stay tuned to this space. We plan to bring more webinars on the same. And also regarding the recorded thing of it, generally at the end of these, we have been having these webinars on different areas of technologies also. So at the end of it, you will get a mail for having attended these sessions, and also that will also contain a place from where you can access the recorded session of this. So thanks a lot for attending this, and look forward to your further participation in the further upcoming webinars also. So thanks a lot, Pavan. So with this, I think we can end today's session.
Sure, my pleasure. Thank you so much.
Thanks.